What would you do if your technically superior tanks, built with precision engineering and featuring the most advanced weapon systems in the world, kept breaking down in freezing temperatures, while your enemy's supposedly inferior machines just kept coming at you, day after day, week after week, rolling through snow that should have stopped them, plowing through mud that should have buried them, and operating in conditions that should have made them completely impossible to run? Most military engineers would assume the problem was inadequate maintenance procedures, insufficient logistical support for spare parts, or simply catastrophic bad luck with unprecedented weather conditions that no reasonable design could have anticipated. But when German Panzer crews first encountered Soviet T-34 medium tanks and KV-1 heavy tanks during the opening weeks of Operation Barbarossa in the summer of 1941, they were initially relieved and even somewhat amused by intelligence reports dismissing these vehicles as crude, unsophisticated designs built by workers who lacked the precision engineering skills and manufacturing excellence that defined German industry, tanks that featured rough welding, loose tolerances, and crude construction that any German engineer could immediately identify as inferior to Panzer workmanship. Then winter came with its brutal Russian cold, and German tank commanders watched in mounting disbelief and frustration as their meticulously engineered Panthers, with their sophisticated interleaved road wheels and Tigers, with their precision Maybach engines, refused to start when temperatures dropped to minus 30 degrees Celsius, while Soviet tanks that had been buried in snowdrifts overnight, left exposed to the elements without the careful maintenance that German doctrine required, somehow fired up their diesel engines immediately at dawn and attacked German positions with the same relentless efficiency they'd shown in summer heat and autumn mud. The Germans were supremely confident at the invasion's start, and their confidence was built on 3 years of unbroken victory across Europe. Their Panzer divisions had conquered Poland in 3 weeks, smashed through France in 6 weeks, destroyed British armor in North Africa, and established Germany as possessing the world's finest armored forces, with tanks that were engineering marvels featuring advanced optical sighting systems that allowed first-shot kills at ranges Soviet crews couldn't even see their targets, superior armor penetration from high-velocity guns designed by the world's best ballistics engineers, and mechanical sophistication that represented the absolute pinnacle of what 1940s technology could achieve. German tankers believed, because their officers and propaganda had told them repeatedly, that one properly designed and manufactured German Panzer was worth 5, maybe 10 of the mass-produced Soviet tanks that emphasized quantity over quality and crude functionality over elegant engineering. But the Germans didn't know about Soviet design philosophy, or more precisely, they knew about it, but fundamentally misunderstood what they were seeing, interpreting deliberate simplicity as evidence of primitive capability, rather than recognizing it as sophisticated adaptation to operational requirements. And they certainly didn't expect that the supposedly inferior Soviet approach, with its wide tracks designed specifically for Russian mud, its simple diesel engines that peasant conscripts with minimal technical training could repair, using sledgehammers and basic wrenches, and its crude but extraordinarily reliable mechanical systems that prioritized function over elegance and battlefield survival over crew comfort, would not only match German technical excellence, but would actually surpass it in the dimension that mattered most in the grinding attrition of the Eastern Front, keeping tanks operational and fighting despite conditions that turned German engineering marvels into immobile steel coffins. This is the story of how Soviet tank designers created weapons that fundamentally confused and increasingly frustrated German engineers who couldn't understand why their objectively superior technology kept failing while Russian tanks just kept working, why the secret to Soviet reliability wasn't advanced engineering but deliberate, calculated simplicity that German precision manufacturing culture viewed as primitive and unacceptable, and how this fundamental philosophical difference in design approach, this clash between sophistication as complexity versus sophistication as simplicity, would help determine the outcome of the largest and most brutal tank battles in human history. Soviet tank designs entering World War II weren't just another generation of armored vehicles competing with German Panzers on relatively equal terms. They represented a radical design philosophy that prioritized mass production capability and battlefield reliability over the technical sophistication and precision engineering that defined German armored doctrine, with the T-34 medium tank and KV-1 heavy tank embodying principles that Soviet designers had refined through hard lessons learned. During rapid industrialization in the 1930s and combat experience in the Spanish Civil War, by the summer of 1941, these Soviet designs represented the culmination of a decade of development that had been shaped by unique constraints and requirements. The knowledge that tanks would be operated by hastily trained peasant conscripts rather than professional soldiers, the certainty that combat would occur in the extreme climate conditions of the Russian steppe and forests where temperatures ranged from -40°C in winter to +40 in summer, and the brutal recognition that Soviet industrial capacity, while growing rapidly, couldn't match German precision manufacturing and therefore had to compete through different advantages. But everything changed on June 22, 1941, when Operation Barbarossa launched the largest invasion in military history, with over 3 million German troops, 3,600 tanks, and 2,700 aircraft crashing across the Soviet border in a campaign that Adolf Hitler and his generals expected to conclude victoriously within 3 months through the proven blitzkrieg doctrine that had conquered most of Europe. The German Panzer divisions that spearheaded this invasion were supremely confident. Their tanks had faced and defeated every opponent they'd encountered in Poland, France, the Balkans, and North Africa, establishing Germany as possessing the world's finest armored forces, whose combination of superior technology, tactical doctrine, and crew training seemed unbeatable. The strategic scope of armored warfare on the Eastern Front would dwarf anything previously seen in military history, with tank battles involving thousands of armored vehicles fighting across fronts spanning hundreds of miles, under conditions where victory depended not just on tactical skill or individual tank superiority, but fundamentally on the ability to keep armor operational through extremes of weather, terrain, and sustained combat that exceeded anything European warfare had previously demanded. The crisis came in stages as German forces penetrated deep into Soviet territory during summer and autumn 1941, with the first shock occurring when Panzer crews encountered T-34 and KV-1 tanks whose sloped armor deflected German anti-tank rounds that should have penetrated easily and whose 76-point guns destroyed German tanks at ranges where German return fire was ineffective. German intelligence had classified Soviet armor as inferior based on pre-war assessments that emphasized crude construction and assumed poor crew training would negate any technical advantages, classifications that proved catastrophically wrong when German tank commanders found themselves facing Soviet armor they couldn't penetrate frontally and whose battlefield performance exceeded what intelligence had predicted. The moment of truth arrived during the first winter of 1941-42 when temperatures plummeted and the German mechanized forces that had driven to the outskirts of Moscow discovered that their equipment simply couldn't function in Russian cold, with tank engines refusing to start, lubricants freezing solid, fuel lines icing over, and complex mechanical systems seizing in temperatures they'd never been designed to withstand. If German armor couldn't maintain operational readiness in Soviet conditions, if their sophisticated panzers became liabilities rather than assets when winter arrived, then their entire doctrine of rapid mechanized warfare would fail. The invasion would stall hundreds of miles from its objectives, and the war that was supposed to end in 3 months would transform into exactly the kind of prolonged attrition struggle that German strategic planning had desperately sought to avoid and that Germany's limited resources made nearly impossible to sustain. To understand why Soviet tanks confounded German expectations and ultimately proved superior in the conditions where the war was actually fought, you must understand the philosophy that shaped their design and the constraints that forced Soviet engineers to make radically different choices than their German counterparts. The genesis of the Soviet approach began in the aftermath of World War I and the Russian Civil War, when the new Soviet state recognized that future wars would require massive mechanized forces, but faced the reality that Soviet industrial capacity was decades behind Western Europe in precision manufacturing and that the workforce available for both building and operating tanks consisted largely of peasants with minimal technical education. Soviet tank development in the 1920s and early 1930s proceeded through purchasing foreign designs and reverse engineering them, with American Christie suspension systems and British Vickers tanks providing templates that Soviet engineers adapted to their specific requirements. Learning through this process that sophisticated foreign designs often failed when subjected to Russian conditions and Soviet manufacturing capabilities. The Spanish Civil War from 1936 to 1939 provided the first real combat testing ground for Soviet armor, where T-26 light tanks and BT series fast tanks fought against German and Italian armor, supporting Franco's nationalists. And the lessons learned were sobering. Soviet tanks performed adequately but revealed vulnerabilities in armor protection and showed that crew training standards were often inadequate for the complex systems that designers had incorporated. These experiences, combined with the industrial limitations that Stalin's rapid industrialization couldn't immediately overcome, forced Soviet tank designers toward a philosophy that would have been unthinkable for German engineers, deliberately choosing simplicity over sophistication, accepting crude construction if it improved reliability, and designing for the assumption that tanks would be operated and maintained by poorly educated conscripts using minimal tools under field conditions that would destroy precision mechanisms. The key Soviet design principles that emerged from this philosophy prioritized mechanical simplicity above all else, with every system designed to have as few parts as possible, and those parts made robust enough to withstand abuse that would destroy more delicate mechanisms. Easy maintenance became a fundamental requirement, with designers constantly asking whether a peasant conscript with a wrench and hammer could repair this system in a muddy field under fire, and if the answer was no, the system was redesigned until the answer became yes. Tolerance for harsh treatment by poorly trained crews meant that Soviet tanks were built to survive operator errors that would cripple German tanks, understanding that crew training would often be measured in weeks rather than months, and that combat stress would cause even trained crews to make mistakes. The famous wide tracks of Soviet tanks, particularly the T-34s' 19.5-inch tracks compared to German tanks' typical 15-16-inch width, weren't aesthetic choices but calculated decisions based on ground pressure physics. Recognizing that Russian mud and snow required maximum weight distribution or tanks would simply bog down and become immobile. The choice of diesel engines over gasoline was perhaps the most significant single decision. Diesel fuel was less flammable when hit by enemy fire, didn't evaporate in summer heat or freeze as easily in winter cold, and diesel engines generally proved more reliable under sustained operation than gasoline engines, though they were heavier and more expensive to manufacture. Sloped armor on the T-34, revolutionary when it appeared in 1940, maximized protection without excessive weight by using angles that increased effective thickness and caused rounds to ricochet, a concept that German engineers understood theoretically, but hadn't implemented until they encountered T-34s and scrambled to copy the approach in the Panther design. The main gun on Soviet tanks prioritized anti-tank capability over the multi-purpose versatility that German doctrine preferred. With the 76.2 mm guns on T-34 and KV-1 designed specifically to defeat armor, rather than serving equally well against infantry, fortifications and tanks reflecting Soviet understanding that the primary threat their tanks would face was German armor, and that specialization beat generalization. When resources were limited, crew comfort was consciously sacrificed for mechanical reliability, with T-34 crews working in cramped conditions that would have been unacceptable in German tanks. But Soviet designers calculated correctly that uncomfortable but victorious crews were preferable to comfortable dead ones, and that internal space used for ammunition and fuel contributed more to combat effectiveness than space used for crew convenience. Loose tolerances that allowed continued function when parts were dirty, worn, or slightly damaged meant that Soviet tanks appeared crude in inspection, but kept fighting in conditions that stopped precisely manufactured German tanks, with clearances between moving parts generous enough that mud, dust, or ice couldn't jam mechanisms that German tight tolerances made vulnerable. What the fundamental difference between German and Soviet tank design represented was a collision between two completely opposed philosophies about how engineering excellence should be defined and what characteristics mattered most in weapons designed for industrial-scale warfare under extreme conditions. German engineering philosophy was rooted in centuries of tradition, emphasizing precision manufacturing and craftsmanship, where quality was measured by tolerances measured in fractions of millimeters, where complex mechanical systems demonstrated the designer's sophistication and the manufacturer's skill, and where every component was expected to meet exacting standards that reflected national pride in German technical superiority. This tradition produced tanks with advanced optics that allowed gunners to identify and engage targets at ranges exceeding 2 kilometers, fire control systems incorporating rangefinders and ballistic calculators that improved first-shot accuracy dramatically, specialized armor configurations using face-hardened steel that maximized protection against specific threats, powerful guns designed to penetrate any armor they might encounter, and careful attention to crew survivability and comfort, based on the understanding that trained tank crews were valuable assets requiring months to replace. The German assumption underlying all of this sophistication was that quality would inevitably triumph over quantity, that one superbly designed and manufactured tank, crewed by professionals, would defeat multiple inferior tanks crewed by poorly trained opponents, and that German technical superiority represented a decisive advantage that Soviet numerical superiority couldn't overcome. The Tiger tank exemplified this German approach in its most extreme form, mounting the feared 80mm gun that could destroy any Allied tank at ranges where return fire was ineffective, protected by armor up to 100mm thick that made it nearly invulnerable to frontal attack. Powered by the sophisticated Maybach HL-230 engine, producing 700 horsepower through a complex transmission, and featuring the intricate interleaved road wheel suspension system that provided excellent ride quality and distributed weight effectively, German crews operating Tigers appreciated the comfortable crew compartment with excellent visibility, the precise optical instruments that made long-range gunnery almost easy, and the knowledge that their armor could withstand hits that would obliterate lighter tanks. But this sophistication came at devastating costs that became apparent only under sustained combat conditions. Each Tiger required approximately 300,000 man-hours to manufacture compared to 3,000 hours for a T-34, meaning that in the time German factories produced one Tiger, Soviet factories produced 100 T-34s. The Tiger's complexity made it mechanically unreliable, particularly in extreme weather, with final drive failures occurring so frequently that many Tigers were lost to mechanical breakdown rather than enemy action. The interleaved road wheels that provided such excellent suspension performance became death traps in Russian winter, when mud packed between the wheels froze overnight into solid ice that immobilized the tank until crews spent hours with blowtorches and hammers chipping the ice away, and this process had to be repeated every single morning in winter conditions. The Tiger's weight of 56 tons created ground pressure that caused it to bog down in mud, where lighter tanks could pass, limited which bridges it could cross, and made recovery of disabled Tigers nearly impossible under combat conditions. Most critically, the Tiger's fuel consumption was so extreme that its operational range rarely exceeded 100 kilometers on roads and was far less cross-country, meaning that Tigers often couldn't pursue retreating enemies or exploit breakthroughs because they'd exhausted their fuel. Soviet design philosophy rejected this entire approach as fundamentally misunderstanding what mattered in the war they knew they'd have to fight. Soviet designers understood that Russian climate conditions ranging from -40°C winters to +40 summers, combined with terrain that alternated between choking dust and bottomless mud depending on season, would destroy precision mechanisms and complex systems faster than enemy fire would. They recognized that the Red Army would never have enough trained mechanics to maintain finicky, sophisticated tanks, that spare parts would often be unavailable at the front, and that repairs would need to be accomplished by tank crews themselves using whatever tools they could scavenge. Most fundamentally, Soviet planners understood that they needed thousands of tanks operational simultaneously across a front spanning thousands of kilometers, and that achieving this operational density required designs that could be mass-produced by semi-skilled workers in factories evacuated to the Urals under emergency conditions, and that would remain functional, despite minimal maintenance and harsh treatment. The result was deliberate simplification that German engineers interpreted as primitive incompetence, but was actually sophisticated adaptation to operational requirements, choosing crude reliability over elegant fragility, accepting that individual Soviet tanks would lose one-on-one duels with German armor, but understanding that 5 T-34s arriving at the battle would defeat 2 Tigers when the other 3 Tigers were immobilized by mechanical failures in their maintenance depot. The initial encounters between German Panzer forces and Soviet armor during Operation Barbarossa's opening weeks in summer 1941 shattered German assumptions about Soviet tank quality in ways that created immediate tactical problems and foreshadowed the strategic disaster that would unfold over the following months and years. German tank crews who had grown accustomed to encountering Polish, French, and British tanks that their guns could penetrate reliably, suddenly found themselves facing T-34s whose sloped armor deflected their standard 37mm and short-barrel 50mm anti-tank rounds at combat ranges, with rounds literally bouncing off Soviet armor and leaving crews helpless as the T-34's 76.2mm gun destroyed their Panzer IIIs and IVs with single shots. The KV-1 heavy tank proved even more shocking, with armor so thick that German tank crews reported firing dozens of rounds at immobilized KV-1s without achieving penetration, requiring 80mm anti-aircraft guns to be brought forward in direct fire mode to destroy these Soviet behemoths. German tactical superiority and vastly better crew training compensated for these technical disadvantages initially, with experienced German crews using superior tactics, better coordination with infantry and artillery, and their excellent optics to engage Soviet tanks from positions where German weaknesses didn't matter. But the psychological impact of discovering that German tanks weren't superior in all dimensions created doubt that would grow throughout the campaign. The summer's heat and dust created the first environmental challenge that revealed reliability differences, with Russian steppe dust so fine and pervasive that it infiltrated every mechanism and clogged air filters that German designers had sized for European conditions. German precision engines with their tight tolerances began suffering failures as dust accumulated in cylinder walls and transmission components, requiring increasingly frequent maintenance that consumed time and resources, while Soviet tanks with their deliberately loose tolerances continued operating with the same dust accumulation that was killing German engines. The autumn Rasputitsa, the seasonal mud period when autumn rains turned Russian roads into rivers of glutinous muck that could swallow vehicles whole, revealed the crucial importance of track width and ground pressure calculations that Soviet designers had prioritized and German engineers had underweighted. German tanks with their narrower tracks sank into mud that T-34s with their wide tracks crossed successfully, and this mobility advantage proved strategically decisive as the German advance that had covered hundreds of kilometers during summer ground to a halt, not because of enemy resistance but because panzers were physically unable to move through terrain that Soviet tanks navigated routinely. German units were forced to abandon tanks stuck so deeply in mud that recovery was impossible, writing off valuable equipment to environmental conditions, while Soviet forces exploited German immobility to launch counterattacks that German doctrine said should have been impossible. But the true catastrophe arrived with winter, when temperatures plummeted and German mechanized forces discovered that their equipment had been designed for a war that would end before winter and simply couldn't function in Russian cold. German tanks using gasoline engines with their lower freezing points found fuel lines icing and engines refusing to start at temperatures below -20 Celsius. German crews spent hours each morning trying to coax frozen engines to life by lighting fires underneath vehicles, or draining oil to heat it over fires before pouring it back into engines. Soviet tanks with their diesel engines started reliably in the same temperatures that paralyzed German armor. The diesel fuel's higher freezing point and the engine's simpler cold start systems meant that T-34 crews could attack at dawn, while German tankers were still trying desperately to get their sophisticated Panthers and Tigers running, creating a situation where technical superiority became meaningless because the superior tanks couldn't move. German tank units reported operational readiness rates dropping below 30% during the winter of 1941-42, not because of combat losses but because their tanks simply wouldn't function in conditions that Soviet designers had anticipated and German engineers had dismissed as improbable. And this mechanical catastrophe contributed as much to the failure to capture Moscow as Soviet military resistance did. The statistical reality of tank production and operational readiness on the Eastern Front told a story that no amount of German tactical brilliance or individual tank superiority could overcome, revealing that Soviet design philosophy had understood something fundamental about industrial warfare that German engineering culture had missed. Soviet factories produced approximately 84,000 T-34 medium tanks during the war years from 1940 to 1945, a number so staggering that it exceeded total German production of all tank types combined, while German industry managed to build roughly 6,000 Tigers and 6,000 Panthers, their most capable designs, over the same period, despite desperate efforts to increase output and despite Germany's vaunted industrial capacity and manufacturing expertise. But these raw production numbers understated Soviet advantages, because they didn't account for operational readiness rates that favored simpler designs. Soviet tank units typically maintained 75 to 80% of their vehicles in operational condition, even during sustained combat operations, while German Panzer divisions struggled to keep 50 to 60% of their strength ready for action, with the remainder deadlined for maintenance, awaiting spare parts or completely broken down. German tanks spent more time in repair facilities than in combat, their sophisticated systems requiring constant attention from increasingly scarce trained mechanics using specialized tools that frontline units often lacked, while Soviet tanks were either fighting or destroyed, rarely sitting idle due to mechanical issues that their simple designs and field repairable components made manageable, even under combat conditions. This meant that even when German tanks achieved the favorable kill ratios that their superior optics and guns often produced, destroying 3 or 4 Soviet tanks for every German loss in direct combat, the strategic arithmetic still favored the Soviets because German losses couldn't be replaced as quickly, and German survivors spent more time immobilized by maintenance requirements. The myth of German technical superiority crashed against the reality that laboratory performance and actual battlefield effectiveness were entirely different measures of success. German tanks were indeed technically superior in controlled conditions, their guns more accurate at long range, their armor better protected against specific threats, their crew stations more ergonomically designed. But the Eastern Front wasn't a controlled environment. It was chaos where tanks fought in dust storms that reduced visibility to meters, in mud that made maneuver impossible, in temperatures that exceeded design specifications by 40 degrees in both directions, and under these real-world conditions, German sophistication became fatal vulnerability, while Soviet crudeness proved to be genius. The Battle of Kursk in July 1943, the largest tank engagement in history involving over 6,000 armored vehicles, demonstrated this principle with brutal clarity, as German forces fielded their newest Panthers and Tigers, expecting technical superiority to overcome Soviet numerical advantages. And initially, German guns achieved exactly the results their designers had promised, destroying Soviet tanks at ranges where Soviet return fire was ineffective. But Panther final drives began failing after just a few days of sustained combat, their complex transmissions unable to handle the stresses that simpler Soviet designs survived routinely, and Tigers broke down from overheating and mechanical failures that reduced German armored strength daily, while Soviet T-34s, despite suffering higher combat losses, maintained operational strength through reliability and the constant flow of replacements from factories that German bombers couldn't reach. The German offensive that was supposed to crush Soviet forces through technical superiority instead ground down through mechanical attrition as much as combat losses, and when the Soviets launched their counter-offensive, they did so with tank forces that remained operational while German repair facilities overflowed, with broken Panthers waiting for parts. German attempts to adapt their designs to Soviet lessons came too late and were compromised by cultural inability to truly embrace simplicity. The Panther incorporated T-34's sloped armor, but remained over-engineered with interleaved wheels that froze and complex systems that required specialized maintenance. And German industry proved incapable of the mass production techniques that Soviet factories had learned from American automobile manufacturing. By 1944, German commanders knew they'd lost the tank warfare battle, not because of inferior tactics or crew quality, but because Soviet design philosophy had proven superior where it mattered, keeping maximum numbers operational under conditions that German precision engineering couldn't handle, and this recognition came far too late to change the outcome. The post-war analysis conducted by military historians, surviving German commanders, and tank designers from both sides produced a consensus that would have seemed impossible in 1941. That Soviet tank design philosophy had been fundamentally superior to German approaches, despite German tanks winning most individual engagements, and that the lesson was profound for understanding how engineering excellence should be measured in weapons designed for industrial-scale warfare under extreme conditions. German engineering excellence was acknowledged and remains respected to this day. The Tiger's 88mm gun was genuinely the most feared tank weapon of the war. German optics were unmatched for quality, and German crew training produced tankers whose individual skill exceeded their opponents. But all of this sophistication was fundamentally misapplied to the operational requirements of the Eastern Front, where keeping tanks running mattered more than making each tank perfect. The recognition that operational reliability trumps technical sophistication when designs must function in harsh conditions became a foundational principle of post-war armored vehicle development, influencing every major tank design for the next 50 years and validating Soviet pragmatism over German perfectionism. The numbers that emerged from detailed studies told a story that couldn't be disputed. 84,000 T-34s produced at roughly one-third the cost of a Panther created a quantitative advantage that German quality could never overcome, particularly when Soviet tanks maintained higher operational readiness rates despite their supposedly crude construction. And when German tanks spent more time broken down than fighting, their technical superiority became irrelevant to strategic outcomes. German veterans writing memoirs and giving interviews decades after the war consistently acknowledged T-34 superiority in the dimensions that mattered most, with tank commanders like Otto Carius and Kurt Knispel, who had personally destroyed hundreds of Soviet tanks, admitting that Soviet design philosophy had been correct for the war that was actually fought rather than the war German planners had expected. The admission that Soviet approaches, that German engineers had dismissed as primitive, were actually sophisticated adaptations to operational requirements, represented a fundamental shift in understanding what constituted good engineering, recognizing that cultural biases toward complexity and precision had blinded German designers to the virtues of deliberate simplicity. The influence on subsequent tank development was immediate and profound, with the T-34 becoming the most influential tank design in history, copied or adapted by dozens of countries and serving as the template for Cold War Soviet armor that would eventually include over 100,000 T-54-55 tanks, the most produced tank design ever, continuing the reliability and simplicity philosophy that had proven so successful. Western armies absorbed Soviet lessons grudgingly but thoroughly, with American and British post-war tanks increasingly prioritizing reliability, adopting diesel engines as standard, incorporating wider tracks for better ground pressure distribution, and emphasizing ease of maintenance over sophistication of systems, all principles that Soviet designers had implemented 2 decades earlier. The philosophical lesson transcended tank warfare and applied to any engineering challenge where sophisticated systems must function in harsh conditions under operator stress. That simplicity is often more sophisticated than complexity when measured by mission accomplishment rather than technical elegance. That designs must match the operational environment and user capabilities rather than pursuing abstract technical perfection, and that maintainability functions as a combat multiplier, more valuable than marginal performance improvements. The modern perspective recognizes that German over-engineering was a strategic weakness disguised as technical strength, that cultural preferences for complexity over simplicity cost Germany the armored warfare battle on the Eastern Front, and that the crude Soviet approach that German engineers had mocked represented engineering genius precisely because it prioritized what mattered, keeping maximum numbers of tanks operational and fighting, rather than building perfect machines that spent most of their time broken. The T-34 that German intelligence dismissed in 1941 as inferior proved to be one of history's most successful weapon designs, not because it was the best tank in any single technical dimension, but because Soviet designers understood that reliability, producibility, and maintainability mattered more than sophistication, and that lesson remains as valid today as it was when German Panzers froze on the approaches to Moscow, while Soviet tanks kept rolling forward through the winter cold that German precision engineering simply couldn't survive.